Hello friends, this is Dr. Antoine, your coach in decision making models. In this video, I'm going to show you another method among multi-criteria decision making methods. Remember, I have already presented the 6 methods, which are weighted sum model, weighted product model, evaluation based on distance from average solution, meet objective optimization on the basis of simple ratio analysis, technique for order preference by similarity to ideal solution, and preference selection index method. And this method, additive ratio assessment ARAS, was developed by these authors in 2010. And this method determines the performance of alternative and set off a comparison between the scores of those alternatives and ideal alternatives. It is compensatory method as it combines beneficial and non-beneficial attributes to get best solution. It relies on quantitative evaluations and the activity theory of value. So, friends, now, as you can see, we are going to work on the same data set or decision matrix that we have been using in previous method. This allows us to make a comparison between the result of our methods. Till now, all 6 methods have presented or have indicated that the car 5 can be bought or is the best car to buy. Now, I want to use another method to see whether the conclusion of this new method will be the same as 6 previous methods that I have already presented in my previous videos. And I'm going to use now additive ratio assessment, and I will make comparison of its result to the previous conclusion of other methods so as to see whether the same result is to see whether the conclusion is consistent with prior conclusions of other methods. Now you see, guys, I'm working with this data set. The problem is car selection. We have 10 cars, that among which we have to choose one car, and you see now the criteria that have been used. I used to evaluate these cars. They are quality, conditions, security, delivery days, fuel consumption, and price. As I said it, you cannot make summation of these values because these values do not have same measure. For instance, it is in euro and it is in days. You cannot make a summation of this value when you are making your assessment. You have to normalize your matrix. But in this method, the first thing we have to do is to find optimal value. To find optimal value, it depends on whether the criteria is beneficial or non-beneficial. For beneficial criteria or beneficial attributes, we will want the higher value, the better. We will desire the maximum value. But for non-beneficial criteria, we need minimum value. Now, friends, we are going to just select the optimal value. Now I use the function here, maximum, because this value, quality, conditions, security are considered the beneficial attribute, but delivery days, fuel consumption, and price are considered a non-beneficial criteria, which I must find the minimum value. To find optimal value, I need to copy all this value so as to identify optimal value like this. I copy these values, and then I will find the maximum value here. This is our decision matrix in which I have to find optimal value equals maximum in this value, which is the maximum in this value. Now you see it is 9, and I can copy this formula until only beneficial attributes. Because on non-beneficial attributes, I need minimum value equal minimum like this, minimum value, because they are non-beneficial, minimum value like this. Okay, this is optimal values for each criteria. And this will help us to make our decision step by step. The next step is the calculating reciprocal values for non-beneficial criteria. Now it means I will take 1 divided by each value of non-beneficial criteria. Now look, I do like this, equal 1 divided by this value, and it is the same formula for all non-beneficial criteria. I can copy only this formula here, because when I copy in all cells, we'll have to say this. We will have trouble to make the format of these numbers will change. All numbers will be like this one. That's why I don't want to copy the formula. But when I finish for the first car, I will make copy of the formula. Yeah. So I do solve this car. I have to do like this. One divided by this value of delivery days, like this. And now I can copy the formula in all rows, like this. I copy this formula in all rows, like you can see here. It is correct. The next step, friends, is to make normalization of our decision matrix. But you have to pay so much attention, because the way for non-beneficial criteria, we will work on this reciprocal value, but for beneficial criteria, we will work on these values. Now, to make a normalization, we have to divide each value by the sum of all rows. Like this, friends. I have to do like this. I have to, for beneficial, what I do like this. I can use this matrix, or I can use this one. No, I use this matrix, this one, but divided by the sum of all these values, like this. I can fix this matrix, and I can copy the formula only here, because I don't want to change the format of my numbers. I will do the same, and I will copy the formula. Look, I take this value of car, I divide by the sum of these values, like this. Now we have to fix this, and then I will drag I will copy the formula. Then I will copy the formula for beneficial on criteria only, because for non-beneficial, I will work on reciprocal values, like this. I can copy down this formula like this, friends. For non-beneficial criteria, I take this value divided by the sum of these values, like this. To copy the formula, I inserted a dollar, and then I close parentheses. Now I can copy only. I can copy all, because I will copy. I will show you how I can restore my forms like this. That's why we didn't want to copy here, like here in this column, like this, because I will get a number like this. But I can just copy the format of this column like this. I use this, and I do this. Okay. Now, friends, I have normalized the matrix. I have finished to normalize my matrix. The next thing is to get or to do weighted normalized matrix. What does it mean? It means taking these values multiplied by the weight of each criteria. Remember, I have said that criteria here weights were given, but remember in PSI method, preference selection index, we didn't need the weight because the weight are calculated in during it is the calculating weight in preference selection index is one of the steps that must be that. Now it's just we need just to take this value multiplied by this value multiplied by this, and so on, this multiplied by this value multiplied by this, and so on and so on. Now it will be easy now because it is just this value multiplied, but this must be fixed multiplied by this value. So equal, now repeat, it is this equal this value multiplied by this value. Now I insert the dollar here so as to copy the formula, and I do this. I can copy only, you see why I don't want to copy down the formula, because I want to keep my format equal, and now I will fix equal this value multiplied by the weights like this. Now I can fix this formula, then I will copy the formula in all for all attributes like this. This is normalized weighted matrix, weighted normalized matrix, weighted normalized matrix. We get now weighted normalized matrix, and the next step is to calculate optimality function, which is the sum of all criteria, the sum of all criteria like this sum, this plus this plus this plus this plus this plus this, it will give us optimality function of alternatives. Now I can do like this, friends, equal function sum, in English this function it will be sum, but in French it's sum. Like this, friends, like this. I select all these values and then I press enter. Now I copy down my formula and I have optimality function of each alternative or each card. Okay, friends. Now among these values, I need the highest value which will help me to calculate the degree of utility. Normally I use this function max to find the maximum value here. Maximum value, where is the maximum value? I press enter. Now you see the maximum value, it is this one. Now I'm going to divide all of these values one by one by this value. Now let's go, friends, to calculate. I'm calculating the degree of utility. This value divided by this one, but pay attention, this must be fixed. You insert dollar before the letter and the number also. Press enter. Now I can drag down my formula for all cars. Now what is next? I can highlight the highest value like this. No, sorry, this cannot be included there in what I want to highlight, because I'm comparing my cars. 10 value, I need one value like this. Now you see the car 5 is selected. Now I can rank all cars, equal rank like this of this value, but I have to show the matrix like this, which will be fixed. The matrix must be fixed like this. like this, inserting dollar symbol like this. Then I press enter, then I select, I copy the formula. Now, as you can see, friend, this car, five car is selected by this new method, and this car, the conclusion of the proposition of the additive rational. The proposition of additive rational assessment is to buy car 5 as it was in the 6 previous methods that I have presented: weighted sum model, weighted product model, evaluation based on distance from average solution, objective optimization on basis of simple ratio analysis, technique for order preference by similarity to ideal solution, and preference selection index method. All these methods concluded that car 5 can be bought. Okay, friends, now I finished my presentation. If you like this video, you can like it, you can share it, and you can also subscribe to my channel so as to get all my videos, because as you can see, I'm giving you some methods that can help you to increase your knowledge and competence. Okay, bye friends, for next video.